This trampoline is magical!
It makes me go up and down!
That's not magic. That's physics.
Physics?
What's physics?
Physics is a natural law that governs matter and energy and the interactions between the two.
Magic is way cooler.
We don't need physics.
Actually, you do. Let me show you.
Woo!
It all started way before our time with Aristotle and Galileo. Although Aristotle came up with many of the earliest theories, Galileo was able to disprove many of them. Interestingly, the year Galileo died, Sir Isaac Newton was born.
Who's that?
Who's Newton? Newton was one of the best physicists of all time. He wrote the book Principia, and his 3 laws are the basis of many areas of physics. Let's go talk about them now.
Law 1. An object in motion will stay in motion, and an object at rest will stay at rest until acted upon by an outside force. Notice how even though the cart stopped, the melons didn't. That's because these premium pet beds were only acting upon the cart and not the melons. And the melons only stopped because they were acted upon by the cart. Newton's second law states that force equals mass of an object times its acceleration.
Here we will demonstrate this law by dropping things on Play-Doh. Since we are dropping them from such a small distance, air resistance is negligible, although the acceleration due to gravity should remain constant.
We have a grape.
And then an orange and a pumpkin.
Okay. As you can see, the grape barely left any mark at all on the Play-Doh. The orange only made a small divot, and the pumpkin smashed it like a pancake. Since acceleration is constant, the difference in force can only be explained by the change in mass.
Since I have a greater mass, I made the biggest force on the Play-Doh.
Newton's third law says every action has an equal and opposite reaction. Watch this. Notice how the force of me pushing on Rose moved her backwards. This same force also pushed me backwards. This is known as a force pair.
So what have we learned today?
Well, an object in motion will stay in motion, and an object at rest will stay in rest unless acted upon by an outside force, given that there is no net force.
Also, the acceleration of an object is directly proportional to its net force and inversely proportional to its mass. The direction of the acceleration is also in the applied net force.
Finally, we learned that when an object exerts a force on a second object, the second object produces an equal and opposite force on the first.
Physics rocks!